One of the more common uses of the sum and difference formulas is to be able to evaluate the values, the exact values, of the angles of trigonometric functions that don't fall necessarily on the unit circle. So take, for instance, sine of 75 degrees. Now, what we'd like to do is we'd like to be able to break 75 up into a sum or difference of some of the angles that do exist in the unit circle. And remember, angles that we have in the unit circle, aside from 0, are 30, 45, 60, and 90 degrees. Okay, so if we can somehow break it up into some sort of sum or difference of these four values, then what we can do is we can use our sum and difference to be able to rewrite this, and then also to use our formulas to evaluate. Now we know 75 can be written as 30 plus 45. And so what we could do is we could rewrite this as the sine of 30 degrees plus 45 degrees. Now think of 30 as x and 45 as y, and we can go into our formulas, and we have this sine of x plus y. Okay, so that's sine x cos y, cos x sine y. And so we can now rewrite this by plugging in 30 for x and then 45 for y as the sine of 30 degrees and the cos of 45 degrees plus the cos of 30 degrees times the sine of 45 degrees. All right. And at this point, now we can either just use this unit circle or we have these memorized and we can evaluate these. Okay, so remember the sine of 30 degrees is 1/2. The cosine of 45 degrees is root 2 over 2. The cosine of 30 degrees is root 3 over 2. And then finally, sine of 45 degrees is root 2 over 2. All right, and again, all you do is you either look in the unit circle. Remember, the sine is the y coordinate for the unit circle, and the cosine is the x coordinate. So if we went into our unit circle, the sine of 30 degrees is 1/2 because it is the y coordinate at 30 degrees. And then 45 degrees, they're both root 2 over 2. And then the cosine of 30 degrees is root 3 over 2. Okay, so that's how I got those. But again, we should probably have those memorized at this point. All right, so now we go ahead and simplify this. 1 times root 2 is just going to be root 2. Root 3 times root 2 is root 6. And then in the denominator, 2 times 2 is 4. Right? Now, we can certainly use a calculator to check this. And so in our calculator, if we were to just go through and say that we had the square root, and I'm going to use a quantity here. So quantity square root, nope, let me clear that. So square root of 2, right? And then plus the square root of 6. And then we divide that by 4. Right? We get that 0.9659. And then if I just typed in the cosine, or the sine, excuse me, of 75 degrees, not sine of ln, we have the sine, well, this is not going well, is it? So the sine of 75 is exactly that. Okay, so that's how we can check our answers to make sure that we're right. We just make sure our calculator's in degree mode and we evaluate. Another example, sine of 7 pi 12ths. Now this one's a little tougher because we have to think in terms of radians, but we can think of 7 pi 12ths as 3 pi 12ths plus 4 pi 12ths, right? And of course, the reason we want to think of it like that is because those both simplify, and that's going to simplify into pi fourths plus pi thirds. Okay, and that's nice because both of those angles are in the unit circle. Okay, of course, we could have converted 7 pi 12ths into degrees and then gone from there. All right, so this is now going to become the sine of pi fourths plus pi thirds. And we can use the exact same formula, sine cos, cos sine. Okay, so we're going to have sine of pi fourths times the cos of pi thirds, and then plus the cos of pi fourths times the sine of pi thirds. Right? And then if we evaluate, we know sine of pi fourths is root 2 over 2. The cos of pi thirds is a half. And then the cos of pi fourths is going to be root 2 over 2. And the sine of pi thirds is root 3 over 2. And as we just saw, this is the exact same thing as the square root of 2 plus the square root of 6 divided by 4. Okay. And again, we should just trust our answer. Or if we don't trust the answer, excuse me, we can just go into our calculator and verify that this is going to be our answer. All right, so this should be the exact same thing. Let's put this in radian mode when we go to our calculator. And so we're going to type in the sine of 7 pi over 12. And look, it gives us the exact same thing, okay, as what we just got right up here, okay? All right, a few more examples. This time we have a cosine of 105. We can rewrite 105 as 60 plus 45. Okay, so remember, we're just trying to utilize those various angles, the 30s, the 45, 60, and 90. And so we can write this as the cosine of 60 degrees plus 45 degrees. And we have a new formula because it's a cosine, right? So if we have the cos of x plus y, that's going to be cos minus sine. Okay, so that's going to be cos of 60 degrees times cos of 45 degrees minus sine of 60 and then sine of 45 degrees. Right? Cosine of 60, a half. Cosine of 45, root 2 over 2. Sine of 60 is going to be root 3 over 2. Sine of 45 is going to be root 2 over 2. Right? And we multiply 1 times 2, or 1 times root 2 is root 2. We have a minus sign. Root 3 times root 2 is root 6. 2 times 2 is 4. Right? Again, checking our answer, we go into our calculator. Let me just change this to a minus, make it quick for us. And then we could type in the cosine of 105 degrees. Let's make sure we're in degree mode. And that gives us negative 0.2588. Up here, we have negative 0.2588. Okay, it's accurate to all the decimal places as well. So, seems like we got it right. Cosine of pi twelfths. Okay, well, pi twelfths we can write as 4 pi twelfths minus 3 pi twelfths. Right, so, or what you could do is you could convert it into degree mode, okay, or degree measure, and then from there you could try to split it up that way. All right, but if we keep it in radians, that might be the easiest way to do it. And so now we can write this as the cosine of 4 pi twelfths, which actually simplifies into pi thirds, and then this is going to be pi fourths when we simplify. Okay, so that's a 4, that's a 3 when we simplify. So it's going to be pi thirds minus pi fourths. Right? We go into our formula sheet, and we notice that cos of x minus y, right? If we look at our formulas, that should be cos plus sine. Okay, so right here, cos of x minus y, cos plus sine. And so this is going to be equal to cos of pi thirds, cos of pi fourths, plus sine of pi thirds, and then sine of pi fourths. All right. And once again, we just do this from memory, or we could use our unit circle either way. Cos of pi thirds, a half. Cos of pi fourths, root 2 over 2. Sine of pi thirds, root 3 over 2. Sine of pi fourths is going to be square root of 2 over 2. And once again, we get our friend root 2 plus root 6 divided by 4. We're going to check this in our calculator just to make sure. So let me change this to a plus. And we'll clear these animals since we don't need them anymore. And we wanted, we're in radian mode, the cosine of pi over 12. All right, and there we go. We get the exact same thing again. All right, so one last example, this time with the tangent. Okay, we haven't seen the tangent too often when we're using our sum and difference formulas, but I certainly don't want to neglect it. We know that 45, or 15, excuse me, can be written as 45 degrees minus 30 degrees. And so this is going to become our tangent of 45 degrees minus 30 degrees, okay? And again, this is something you're going to have to just play around with, okay? So you just use trial and error. Just try, remember, our angles that we have are 30, 60, 45, and 90 degrees. And if we use those, or some semblance or some ordering of these, we should be able to get to these angles like the ones that I'll give you, okay? I'm certainly not going to give you one that's outside of here. All right, so let's look at our formula sheet. We need a tan of x minus y, where x is 45 and y is 30, right? And so in our unit circle, or I'm sorry, in our formula sheet, if we have tan of x minus y, that's going to be tan x minus tan y, 1 plus tan x tan y, right? So that's going to be tan of 45 degrees minus tan of 30 degrees divided by 1 plus the tangent of 45 degrees times the tangent of 30 degrees. All right. So now let's go ahead and maybe figure out what the tangent of 45 and the tangent of 30 are. Remember, in our unit circle, the tangent function or the tangent of an angle is y over x, right? So the tangent of 45 degrees, if we go into our unit circle at 45 degrees, we have root 2 over 2 divided by root 2 over 2. And again, if we have these memorized, it makes it really easy for us, okay? So that's just going to be 1, which is nice. The tan of 30 degrees, okay? That's going to be a little bit more difficult, okay? So that's going to be, if we go into our unit circle, all right, that's going to be our 1/2 over root 3 over 2. Okay, so that's going to be 1/2 divided by root 3 over 2, okay? Which we can certainly write as 1/2 times 2 over root 3, or 1 over root 3, or if we rationalize it, all right, and this is where it's going to get a little bit ugly, that's going to be root 3 over 3. All right, so these are the two values that we're going to substitute all the way back in for our tan of 45 and our tan of 30 in this expression. All right, now we do have to clean that up when we're done. Okay, so this is going to be equal to 1 minus root 3 over 3 divided by 1 plus 1 times root 3 over 3. All right, now here's a trick that we can use algebraically. All right, we notice that we have these complex fractions. Okay, we don't like that. So what I'm going to do is I'm going to clean this up by multiplying by 3 on top and 3 on the bottom. Okay, so this is an algebraic trick that we can use to clean this up. And so if I multiply everything by 3, what that's going to do is it's going to cancel out those complex denominators, okay, or the complex fraction. Okay, so that's going to turn into, so 3 times 1 is 3. Then we have a square root of 3. So we have 3 minus square root of 3. And then we're going to divide that by 3 plus the square root of 3. All right, now, unfortunately for us, the directions all the way back at the beginning of this problem tell us to rationalize the answer if needed. Okay, and unfortunately, anytime there's a radical in the denominator, it's still not rationalized. So what we have to do is, because there's 2 terms in the denominator, we have to multiply by the conjugate. And the conjugate of 3 plus square root of 3 is going to be 3 minus the square root of 3. Okay, so I'm going to have to multiply through by that. And so if I do so, now this becomes 2 FOIL problems. Okay, so I'm going to have to FOIL the top and FOIL the denominator. And so if I do that, 3 times 3, 9. 3 times negative root 3 is negative 3 roots of 3. Negative root 3 times 3 is another 3 roots of 3. And then negative root 3 times negative root 3 is going to be a positive square root of, or just positive 3, excuse me. In the denominator, 3 times 3, 9. And then 3 times negative root 3 is a negative 3 roots of 3. The interior terms become a positive 3 roots of 3. And then finally, root 3 times negative root 3 is going to be a negative 3. Now, certainly we can simplify this a little bit. Okay? And so we have, in the numerator, we have 9 plus 3 is 12. negative 3 roots of 3 and negative 3 roots of 3 becomes negative 6 roots of 3. In the denominator, these are opposites and they cancel. And then 9 minus 3 is 6. And then notice that everything is divisible by 6. Okay, so finally we can write this as 12 over 6 minus 6 roots of 3 over 6. And our final answer for this exact answer should be 2 minus the square root of 3. All right, so that is the precise value, hopefully, of the tangent of 15 degrees. How do we check it? We go to our calculator. Okay, so in our calculator, let's make sure we're in degree mode. We type in the tangent of 15 degrees. All right, so that gives us this number, which most of us have no clue if that's the same thing as 2 minus root 3. 2 minus the square root of 3 is precisely that number. Okay, so and this is some of the algebra technique that you're going to have to use quite frequently, especially with the tangent. Okay, clearing out a complex fraction by multiplying by whatever the denominator is, but then also going through and multiplying by the conjugate. Okay, so remember, when you change the sign in the middle and multiply, that's called the conjugate. Sorry, let me write that in there. So, okay, so multiplying by the conjugate, and you might remember seeing that in basic algebra, but if not, then just revisiting that technique. Okay, so remember, we're going to be using this quite frequently throughout the course as well. All right, so that's all we have to do with respect to evaluating these special sorts of angles. Okay, so remember, breaking them up into these measures, 30, 60, 45, and 90, and then using our sum and difference formulas.